This 2 weeks, we will focus on another topic, which is how to implement serverless application by using few more AWS service. So before we start to implement a serverless application, I'd like to very briefly talking about microservice. Because some people say microservice is a way to design an application, and the serverless is a way to run an application. Okay, so first that's why first I like to talk a little bit about microservice architecture. Okay, so before we're talking about microservice, and then so we talk about monolithic architecture, which we very familiar with because majority time we still use this architecture. Okay, so this one is we called unified model for designing a software solution. And in other words, all piece, composed all in one piece. And then so one piece we call application, right? So this one is monolithic software is designed to be self-contained. Components of the software are interconnected and interdependent. And then so just to use one classical or typical monolithic architecture of 3-tier application. I guess until now, when you guys did Lab 3, and some of you for the project, some of you implement a web app to be the client to consume your published API. And then so still we just use we're following this architecture. We have a data layer, yes. So for this course, majority time the data is in the cloud, right? But still we are using monolithic architecture. Only difference here is in this course, the database is in the cloud, right? And then so here's application layer. So for sure, the application layer, you can see we have a data access, and we have business entities or business model, and then so business layer, server side service layer. And then so here we have application program interface, and here we just use this is a presentation layer. Yes, some majority of them we are able to put in or embedded in certain tier, because we're talking about 3-tier, right? But some of them may need cross the tiers of different tiers and this part, okay? So for instance, for the security, when we're talking about in the data layer, yes, we need to think about security, and for sure, and communications and logins and cachings and exception management. Okay, so the good thing here is the layering helps to segregate concerns But more layers can make changes harder and slow to implement. Means what? Nowadays, every people talking about faster to the market, faster to the market. This is first. Second, since nowadays since it's changing so rapidly, and then the application is the same. It's just because user requirement keeps on changing. So for sure, the application also need to be easily or faster to be changed. Okay, so because of this, and then so people think about another architecture. Okay, so here is that's why like people think about a microservice architecture. So this one is basically is a modular approach. So which means we just like we just integrate many maybe a couple of models together to form application. Okay, so the thing here is the a software application is built with an independent group of components that run each application process as a service. Okay, as a service. So these types of architecture is loosely coupled. Okay, loosely coupled, and then so a component is independent of the other one. In this case, even each component can be written in different programming language, use different data storage, and serves only one specific function. Okay, specific function. So which means what? We do one thing but do it well. Okay, do one thing, do it well. In other words, here is when we're talking about a pattern, there's some sort of principles. One principle is we try to do one thing, but just to do one thing, we're able to do it well. Okay, so this is we're talking about Microsoft architecture. Okay, so here is something I'm just using this example to the example I'm already provide you the link here. Okay, the link here, and then maybe I just I can just copy this link to here, and then so you can take a look there. Okay, and then so here is this one is provided by Microsoft. Okay, so this is talking about E sharp on containers. Okay, E sharp, but I'm not talking about container stuff. Okay, so right now I'm just like to use this example to demonstrate. We say different. I mean, one application is composed by different independent components. Okay, so let's say we take a look here. Very simple example, okay? If we're talking about E sharp, traditional web app, okay? E sharp, or we say e-commerce, okay? E-commerce. When we're talking about e-commerce, classical component, we need to have what? We need to have a component to handle items in basket. And also we need to have ordering component, process users order. And also we need to have catalog component, and we need to have what? Identity, just to manage what? Manage users' credentials, right? That's why we say identity. So you can see here, each one. So for the basket, okay, so for the how to handle the basket, and then so we implement a basket microservice. And then so in this case, you can see this service, basket service, they have their own data source, okay? And then so take a look here. Here is order. How to process ordering. This is we call ordering microservice. Okay, ordering microservice, and then so you can see, and the ordering microservice have their own data source, and here they use what? They assume, okay, we use the data is stored in the SQL Server database. And also here we have catalog microservice. Okay, so they also put their data in the SQL Server. Here is identity. Okay, so you can see here different microservice or different component of the same app, one app, different components. They have their own data source. Okay, they have their own data source. Because they have their own data source, for sure they have their own data access layer, right? Okay, so each of them can be existed independently. Okay, independently. But after saying that, for sure, and then so let's say this ordering service, and then so the basket, and then so for sure they may need to communicate with each other. Communicate with each other, especially if we just put one more thing here is if this ordering, this part underlying, you can see the background task, and this one really need to modify the inventory correspondingly, right? And then so for sure they need to communicate with each other. And how can they communicate with each other? There is so many ways, okay? So many ways. And the first way could be we just use invent bus, okay? So let's say I know you guys have already known the rapid message queue, right? And also Azure also provide Azure Service Bus. And do you remember when we're talking about in AWS, they have what? They have a queue, right? Simple queue service, do you remember? And then so they also have simple notification service, okay? So these things can also be used to or can be also used to facilitate the different components, how they communicate with each other, okay? Communicate with each other. So that's the good thing. Okay, so here is we said that's the good thing. Okay, so way back to here, and then so here is the characteristics of microservices. First one, each microservice they have what we call autonomous. Each component in a Microsoft can be developed, deployed, operated, and scaled without affecting the function of other services. So let's say here you have already done project. So let's say here because majority time can you see this is API, okay? So majority time the microservice can be can be implemented as the API, okay, as the API. And then so the API we already know anyone can whoever interested in this use this service, yes, they are able to access it. Okay, they are able to access it. This is the first. So it could be API, and it could be another thing like today we were talking about AWS Lambda. Okay, so they are independent. Okay, they are independent. Because they are independent, so for sure it will be easy for us. Well, if we just like to modify it, and also it can be developed, deployed, operated, and scaled without affecting the other services. This is first. Second, I think this is one of the key, specialized. So each service is designed for a set of capabilities and focus on solving a specific problem. Let's say ordering microservices, just to focus on ordering, how to handle ordering. Let's say the basket microservice really focus on how to handle users basket. Okay, in other words, how to handle those items the user put in the basket. Right. This is what. Yeah. Each service, each microservice focus on one specific function. Okay, provide specific function. And another thing here is selective scalability. So this is very important when we're talking about scalability. We already know what is scalability, right? We're talking about we even provide very accurate definition for the scalability. So here is microservice allow each service to be independently scaled to meet demand for the application's feature it supports. It's pretty straightforward because each microservice is what? It's independent. So that's why we can handle each service in like separately. Okay, so if we just like to scale up or scale down the service, yes, there will be no impact on the others. So we are able to selectively scale up or scale down one particular service, microservice. So easy to deploy, yes, it's just because what? Yes, because each of them are independent. So because of this, it will be easy for us to use CDCI, which means continuous integration, continuous delivery for particular microservice. So make it easy to try out new ideas and roll back if something doesn't work as we expected. So this is a good thing, right? The third thing here is technology freedom. As we mentioned, each microservice, they're independent, they're able to you even be able to implement in different programming language, and also it can be they can have their own data source. So because of this, for sure, that one can be easily to be reused. Okay, but not all the things is really a good thing, right? It's not always good. We say no technology is perfect. They also, yes, while they bring benefits, they also bring challenge as well. Okay, so how to control the communications between microservice, that one is really important. Okay, and also it's quite complicated. Okay, not easy to do. So that's why there are so many right now. There's so many companies try so many proposals, so many different solutions there. Let's say a RabbitMQ is one of them. Okay, so this is first. And second, monitoring. because what each of them, they're independent. How to monitor the application, okay, is also not easy. So we say, yeah, we may need a centralized place to check logs or monitors problems. And also, developers' productivity may not as high as people use monolithic architecture. Okay, so this is we're talking about this one. In terms of the microservice, how we are able to host it. There's so many options there. Okay, so yes, for sure we can the microservice can be hosted in container, right? So we already do you remember in to do API? Yes, this can be part of we can think it as also as what we followed microservice, this kind of idea. And yes, if it is container, yes, we can run anywhere, and also can run locally, and all the things, okay, and also can be like hosted in the platform as a service. We already use what let's say we use Elastic Beanstalk, right? We can host that one in Elastic Beanstalk, but for sure, if you like, you can also run it on a virtual machine, right? There's so many, many different ways. So here is how the architecture and Microsoft's microservice architecture to be serverless. Okay, to be serverless. As we mentioned a moment ago, people say serverless is a way to run an application. Okay, so before we always like to have full control on our product. But we already know nowadays, yes, we can leverage. Let's say when we do lab 3 and the project, we leverage AWS services, right? And then so let's say for the RDS, we use RDS, right? And then for this case, yeah, we really leverage Amazon's RDS service, so that we do not need to worry about how to maintain our database server, how to monitoring all these kind of things. Okay, and then so here is that's why we use fully managed service. So nowadays, people maybe need to change their mind, change from always think about have full control, to leverage third parties service. Okay, so here is when we're talking about the fully managed service, one of these things is RDS, right? We use that one for quite a while, and then so DynamoDB, and then so this one is for the fully managed and zero administration and high availability based on the usage, as if your application, if your business are becoming more and more popular, and more user use your let's say use your business, access your business, and then so the resource you may to support this service also need to increase as well. And this in this case is if in the cloud, we just very easy to provision, and also even it can be automatically scale up or scale down for us, right? This one, and the second one is the developer productivity. We can focus on the code that matters, because we use that, and can innovate rapidly. So many times nowadays people talking about innovation, right? Here is continuous scaling. We're already talking about that one. We're already quite familiar with this. Okay, so back to here. So we talk also people talking about serverless is a way to run an application. So what exactly a server is? What is serverless? Serverless, it is a buzzword have been a buzzword for quite a while. Okay, so but if we're talking about it seems it doesn't mean without server is not right. Okay, so the serverless doesn't mean server are no longer involved. It is simply meaning being a developer, being an owner of the service or the application, we do not need to worry about to manage the server because we use what? We can use fully managed service or leverage fully managed service provided by third party. Let's say nowadays is what? Cloud. Okay, cloud service provider. Okay, cloud service provider. This is the very key things, and also people talking about what serverless architectures. Okay, so here is serverless architectures application designs that incorporate third-party backend service and include custom code run in managed familiar containers on a function as a service platform. Okay, service platform. And then but again, the underlying or fundamental thing is two things. I just like to point it out. Two things. First thing, it doesn't mean there's no server. Second, we leverage third-party service. So nowadays, the third-party service, we're always talking about what? Cloud service provider. Okay, cloud service provider. So the good thing here is for the serverless benefits. So here is pay only for compute time of each request, and no infrastructure we need to manage, and normally it is stateless. So implementation of a microservice architecture, AWS provide too. Okay, AWS has integrated building blocks that support the development of microservice architecture. It provides two popular approaches. The first one is AWS Lambda. It's enable you to run code without provisioning and managing server, and you pay only for the compute time you consume. And this one will be what will be this 2 weeks focus. And second one is AWS Fargate. We tried that one, right? Do you remember when we just try to publish our API to ECS by using what? By using, yes, endline is AWS Fargate. Okay, so not using EC2, right? Do you remember? So after we published the API actually. Is what from the load balance we get that one, but there's no EC2 instances there. Did you notice the difference? If we publish the application to Elastic Beanstalk will instantiate, will provision a EC2 instance for us, which is we already know is what is a computer, right? And when we just publish the API by using ECS, Elastic Container Service, actually there is no EC2 instance. Instead, we have what? We have a load balancer, right? Okay, so they're different. Okay. So here is the AWS Fargate. Okay, so now I'm just like to Move to the another content we're talking about lambda. Okay, we're talking about lambda function. Okay, so this is I guess you already see lab 4 I already released, and then so lab 4 you are asked to implement 2 lambda functions, and then so using step functions to orchestrate to these 2 lambda functions and work together, and we just automate workflow. Okay, workflow, and this is also we call the serverless application. But before we're talking about a serverless application, today we will mainly focus on AWS Lambda. Okay, AWS Lambda. So what is AWS Lambda? We can just very briefly talking about that one. So AWS Lambda, which was launched in 2014, is a compute service that allows you run code without provisioning or managing servers. So it is AWS serverless service. You pay only for the compute time you consume, and there's no charge when your code is not run. So how can we just use the AWS Lambda, or how the AWS Lambda will be triggered to run? Basically there are 3 ways. Okay, the first way is just there are request response invocation type. The second one is event invocation type, and the event can be raised in AWS is that can be executed asynchronously. There are so many available triggers. Okay, so many AWS service will raise event, and this event can be used to trigger your Lambda function. Okay, and the third one is API calls made using the AWS SDK. We're already quite familiar with that one. And then so AWS Lambda supported a set of languages. Okay, so take a look. I'm just like to let me log into my AWS account. Okay. Let's see the service. Okay, so because this service is what? This service belong to compute service. Okay, compute service. And then so for the compute service, so far we're already talking about what? We're already talking about EC2 service. We're already talking about Elastic Beanstalk. So today we were talking about this. Lambda. Okay, so take a look here. I'm already have created 2 lambda there. So you can see we are able to, I'm just show you this. Okay, so let's say I click create function. I click from the scratch. You can see the runtime. Okay, take a look. The supported runtime, the latest support, they support .NET Core 3.1, so Go, and Java 11, and then so Node.js 14, Python, 3.9, Ruby 2.7. This is the latest support, and they are at the same time they also support what? They also support Java on Amazon Linux, Node.js 12.x, and then so here is, yes, they also support Python 3.6, 3.7, 3.8, right? And after that, they also provide what? Yeah, costumed runtime. And then so here is that I just show you, yeah, this we're talking about supported runtime, okay, language. And then so the functions with the scenario, usage scenarios of Lambda functions. The functions with a small amount of execution time. Let's say we just log on the fly, or automated backups, or process uploaded S3, and we were talking about this one, okay? Backend cleaning up and bulk real-time data processing. Majority of time, the Lambda function, AWS Lambda function, will integrate with other AWS services. Let's say S3, let's say recognition service, which we were talking about today, okay, And then, so here is a secure AWS Lambda function. This is AWS Lambda functions include two types of permissions. The first one, execution permission, and the second one is invocation permission. So execution permission is enable AWS Lambda function to access other AWS resources in your account. Okay, in your account. And the invocation permission, or permission that event source need to communicate with your AWS Lambda function. Okay, so that's why I like to go to the, okay, I like you to follow me. So now I just need to go to IAM service. I need to add permission to the user. Okay, so I have this user. I'm still like to use this user. Okay, so we take a look. Okay, you can see I already add what? I already add Amazon. Sorry, not this one. I already add AWS Lambda for access. Okay, so I already add that one. Can you just do the same thing? Add permission and add AWS Lambda for access to the user you like to use to do today's follow me to do today's example. Okay. And then so here is the components of what? Components of AWS Lambda. First, we need to have Lambda function, the code that runs on AWS Lambda. The second, we need to know, we need to specify the event source. Okay, event source. The event source is what? Associate your function with the specific AWS source. Okay, I will just show you. And then so the AWS Lambda service and AWS Lambda runtime. Okay, Lambda runtime. Okay, so and then so here is security and here is execution time. Okay, so now all calls made to the AWS Lambda must be completed within 15 minutes, no days. Okay, the default timeout is 30 seconds, but you can just set a timeout between 1 to 900. The unit they use is a second. Okay, is a second. So now I'm just like to launch Visual Studio, and then so I just like to show you implement a very first Lambda AWS Lambda function. Okay. Use C# Lambda. Okay. So you can see here, I am just like to choose the first one, AWS Lambda Project.NET Core. They do not support .NET 5 yet. Okay. They do not have this runtime. Do you remember a moment ago when we see the runtime? They have .NET Core 3.1, right? .NET Core 3.1. They do not support .NET 5 yet. Okay, so we choose this one. We choose a C# project for creating AWS Lambda functions using .NET Core. Okay, so I'm just choose that one and click next. So I just like to choose choose the folder, and then so I'm just say the lambda function. We are section 1. Okay, for section 001. Okay, so click create. And then so here you can see they support, they already provide a bunch of blueprint. Okay, so what is a blueprint? You can see the blueprints are Lambda project that contain getting started code for your functions and the test projects. Okay, so choose blueprint that best aligns with your desired scenario and customized as needed for sure. So very first one, I will just choose the empty function, and then so the second one we will just choose this. Okay.
So if we choose one and it turns out to be different from like what we want, is it possible like change one so it's exactly the same as like another one?
Yes, for sure. Yes, you can change.
So
they just
they're all the same.
Yeah, they're the same. I mean, yeah. So can you see? We just let's say first one we just choose the empty function, right?
Right.
But because being a developer, we always like to reuse the code they provided, right?
Yeah.
So just to make our life a little bit easier, right? But for sure, yes, like you mentioned, yeah. And I realized I made mistake. Yeah, you for sure you can change, right? Being a developer, for sure we are able to change the code, right?
All right. Yeah. Thanks.
Okay. Choose empty function. Click finish. So here is, yes, they create what? For sure, they create some sort of skeleton for us, okay? So take a look here. I'd really like you to pay attention to the structure of the project, okay? So here they have Lambda, AWS Lambda tools default. Yes, for sure they have a function.cs file. Let's take a look at the function.cs file, okay? So this is what, this you can see this is, class name. We already very familiar with that one. And here is the function handler. Basically, this is the start point, entry point of your Lambda function. Okay, entry point of this Lambda function. And then so here what we try to do here is, okay, when this function will be triggered, and then so we provide input here. You can see the first the Lambda function handler. This is what this is. You can see it's very much like what we quite familiar with event handler, right? in programming 3, we're always talking about event handler, especially we're talking about the delegate, right? So they also provide some sort of what we already know. This is the signature. Okay, the first parameter is what? Is the data you need to pass to this lambda, and the second one here is I lambda context. Okay, so when we're talking about context, so now we already see DB context class. We're already talking about the DynamoDB context class as well. Okay, so now we're talking about Lambda context. Okay, so but for sure here is what? Yep, if you see this definition, basically they contains this is an interface. Whoever implemented this interface, and then so we can get what? Yes, we have a function name. Have function versions and identities and invocation function ARM. Okay, we already know here is AWS resource name, right? And also have what bunch of informations here. Let's say the memory limit. Limit in MB, so we were talking about that one when we run it, you will understand it better. Okay, so now here is what we try to do here. Very simple. It's just based on capitalize the input. Okay, capitalize the input and change that one to what? To uppercase. Okay, and then so this is what. Yeah, take a look. This is assembly, and this one lambda serializer. This is to, you can see, to what? To convert. Can you see? We convert the whatever convert the JSON to where? To the class or to the object of the C# class. Okay, to the object of C# class. What we try to do here, okay, let's mark it. Okay, run it. You can see here a mock lambda test tool, and we can run it. So they provide this, and then so here is AWS .NET Core, because this is our runtime, right? And then so this is a config file which is included in the being part of the project, right? And here is a credential and AWS region. I'm using Ohio. And then so here is the function name. Okay, so the function name here is the sort of a format. Here is the assembly name. Okay, here is the assembly name, and this is the qualified or full name of the function, which is a class name, right? And here is what the entry point, as we mentioned, the entry point of this lambda function, which is a function handler. Okay, this is the format. Okay, this is the format. And then so here is input. I'm just using what? This is hello, right? I guess. Okay, let's just run it, because that one is it is a string, right? So here is the output, because the lambda, what we do here is the function handler. Lambda function handler is to what? It's just to capitalize whatever we have already input, right? Or we say capitalize the input string. Okay, capitalize the input string. Okay, and this is, we just use that one to test to see whether we are able to get the right result. Okay, so let's back to here one more time. And then so in this case, how about I don't like to do this. I just like to say, oh yeah, this lambda function is just like to generate greeting greet message. And then so in this case, instead of the input, this is a string, I may just use another types of, let's say, student class or person class. Okay, we just modify that one a little bit, and then so after we back to do it after we take 5 minutes break. Okay, so let me wait just back at 9:31. Okay, back at 9:31, and then so we resume the class. Okay, so again, as I mentioned, I'm just like to return, instead of say using stream, I'm just like to add one class. Let's say very simple. Okay, so this class, let's say I'm just to put what employees class, and this employee class has what provide name, and provide email address. Okay, then so in the function, instead of say using string, I'm just use what here is employee, and then so here is not employee to, I think we need to get employees, let's say name. Okay, return name. And then so here is what maybe you just say are we able to do that way? I think we could, right? Can we? Are we able to do this? Right? Okay, so just a great message. Okay, so now we just test it one more time. Okay, test it one more time. Let's see. So this time the input here is we need to input what? We need to input name, right? I just put my name here. And then so here the second one is email address, right? Let's say I put hotmail.com. Okay, let's see.
Professor, how do we have to go in this page? How do we have to go in this page?
Okay.
AWS.
This one.
Oh, okay.
Okay. In other words, we run it, okay? I'm just provide, here is name, and provide what? My name here. And then so here is, yes, I provide email address. And okay, so now we already provide the input, right? And execute. I hope we get that one. Yes, we do get this output, right? This output is what we expected, right? Okay, you get it? Do you get it, guys? How come I'm not able to see it? Okay, here we go. You get that one, right? Okay. So now it seems the lambda function can work as we expected. Okay, so in this case, next step, we can publish it. Okay, and then okay, so one more time, just to say this. This is Lambda tools. Okay, take a look what we have here. So basically, they provide profile, the region, configuration, framework, and here is the runtime, and here is the function memory size. By default is 256 KB. Function timeout 30 means what? 30 seconds, as we mentioned. Maximum so far, a lambda function can run or can last maximum 15 minutes. Okay, 15 minutes. So here is a function handler we already talking about. This the first part is assembly, and the second part is the functions, fully qualified name, and the third part is engine point of the lambda function, which is what? Method name, right? Which is method name. Okay, so now I'm just like to we build it. Okay, so for sure. And then so after that, right click, and this time we publish to AWS Lambda. Okay, we publish to AWS Lambda, and then so I just do one more time, publish to AWS Lambda, and then so here is the credential. We're already very familiar with that one. And here is what? US East. I'm just using US East 2, okay? And the package type is zip, lambda runtime. Yes, this one is .NET Core. And the architecture, I choose this one because it seems that this one is a little bit cheaper, but if you like, you can choose ARM. Okay, so now we need to provide the function name. Okay, the function name here, this is my function name. I'm just use what? Lambda function. How come I just say 3? Okay, yeah. Section 001. Okay, so description. This is my first lambda function. Okay, this lambda function. Okay, this refer to. Okay, and for let's say for section 001. Okay, release. Here is the framework, and then so just bear in mind the handler. Okay, so here is. You can see by default they already provide us. Okay, so this is again, take a look, this. Okay, so assembly, and here is the type. Basically here is your what? Your lambda function type. Okay, lambda function type, it is a function. And method, again, this is what? And the engine point function. Okay, and I'm just like to by default the save settings to this configuration for future deployment. I just check that one. Okay, so click next, and here is the role name. Okay, I'm just to choose what I am just like to choose lambda function role to run lambda function. Okay, so take a look here. Here's the memory, okay? So, and here's the timeout. You can see the unit is seconds. As we mentioned, right now the maximum, the lambda function can last maximum 15 minutes. In other words, this lambda function need to be finished within 15 minutes, okay? So 15 minutes, which is 900 seconds, okay? So here is the memory. So you can see, you can choose, they provide, you can see the maximum memory they provide. We can use what? 3008. This is KB, okay? So basically, the memory, the size of a memory is corresponding to the compute power, okay, to the compute power. So now, because this one is very simple, I'm just, the default one is already enough for me. Here is the VPC. We're already very familiar with the VPC, right? So if your function access resources in a VPC, select a list of subnets and a security group. As far as we know, this one we do not need to access any resources, right? Okay. So I don't choose this one, and then so we click upload. Okay, so here is also, I do not choose what. Do you remember? This is the dead letter Q, okay? And please don't choose that, enable this one, because this one will what? Charge us money, okay? Charge us money. So I'm just upload. This is our very first one, right? Okay, so it will, so it's now it is okay. Okay, so I can
I don't have existing role name, so which one do I need to select?
Can you just share your screen with us?
Okay, sure. Here, can you see my screen, Professor?
Yeah. Can you just there's a drop down, right?
Yes.
There's a drop down. You can, here is you can see that you have a existing. Okay, so lambda, here is lambda basic execution. You can choose basic execution.
Okay.
AWS lambda, we take a look.
Okay, Professor, thank you.
Okay, you're welcome. So we take a look there. Okay.
Okay, thank you.
Yeah. Let's see. Yes, you can see it is okay now. I'm just a provide what again. It's a provide name. Here I'm just provide. Here is what email address. Okay, let's just run it. Hope it works. Yes, that's what we get, right? That's what we get. We take a look. We can see we are able to run here. But do you get the result? Okay. So now we just back to the AWS and take a look. Go to the compute service and take a look at lambda, and then so you can see here is functions. I have 3 functions here, okay? I have three functions here. The one we published. This is the one we published a moment ago, right? And then so yeah, you can see just 4 minutes ago. I click. We dive into. And then so this one, yes, we are able to add a trigger, okay? But for this one, we do not need to have any sort of a trigger here, right? No event, okay? So we can take a look the configure, okay? Configure here. Here is the configure we specify. This is what the memory is. The memory is 256 MB. Okay, so I guess I made mistake. A moment ago I said KB, right? It's MB, and the timeout is 30 seconds. Okay, 30 seconds. Then so. For sure, you can see if you think as the time passes, you think, oh yeah, this is not enough. You can edit it. Okay, you can edit it. Even after you publish, you are able to edit it. Okay, so now I'm just like to test it. Okay, so you can see here is we can test it. Okay, so here is name. Provide here, and then so the second one is email address. Okay, so here is, let's say I just provide, and because we only have, okay, so we can test it. Okay, take a look whether we are able to get the result. So here is execution result is what is succeeded, and then so here is the output. Can you see here? Here is the output, and here is the summary. Here is the duration is what is 0.89 milliseconds. The resource configured is 256 MB, and here is the build duration is what is 1 millisecond, and here is the max memory use has already been used is 52. So in other words, you can see this time, if I'm just to keep this lambda function in my account, only when I run it, and this is what? This is the build duration. So far, I only consume 1 milliseconds. Does it make sense? That's why we said lambda function is what? As if your code you publish there, right? But if you do not, there's no the lambda function has not been run or has not been executed, there will be no charge. It's not like what? It's not like when we publish the application to Elastic Beanstalk. It doesn't matter this application processed the request or not, always being charged because you consume the EC2 instance, right? Does it make sense? That one I like you really to bear in mind. Okay, so that's why we say, okay, so this is what based on the use, okay, based on the usage you have already consumed, you have already used. So this is the function ARM. We already know it, which is Amazon resource name, right? Amazon resource name. Okay. Okay. So this is the very first one. Okay, very first one. But you may say, Miss, we didn't do anything, any meaningful thing. I think you're right. Okay, so now we just like to consume. Okay, so take a look at this one. Just like to explain a little bit more. Function handler. Again, as we mentioned, this is the engine point of your Lambda function. So here is event object, contains information about the event and the source that triggered the Lambda function. And the context objects, we already mentioned, provide a number of useful properties, a function name, function version, I'm already show you. And then so here is a callback function. So a moment ago, the example I show you, no, we didn't use that one. And the login, yes, you can just log into the CloudWatch. Okay. So now I'm just like to do what? So now we like to use a Lambda, Amazon's another service, which is a big part of the machine learning. So we call it Amazon Recognition Service. So this service was launched in 2016. And video support was added in 2017. Okay, let's see here. We're back to our. And I will log in, right? Okay, so here we go. And then, so this service belong machine learning, is under the machine learning umbrella. Recognition service. Okay, here we go. This one. We will use this service when you do lab 4. You also need to use this service, Amazon Recognition Service. Take a look, is very popular now. Okay, so the Amazon Recognition Service is what? Is a deep learning based visual analysis service. We search, verify, organize millions of images and videos. Basically, we will just so you can see here. We are able to use this recognition service to leverage to analyze the image and or video. Okay, so this is what we are able to detect object unique to your business. But we will do this one. Okay, integrate with AWS service, which means now we just like to integrate recognition service with what? With AWS Lambda. And then so what we like to do here is whenever user upload an image to a bucket, and then so we like to use recognition service, get the tag, always say tag for the image. Let's say there's tree, or there's man, or just figure out or analyze this picture and grab some information from there. Okay, so this one we will just the second Lambda function I like to demo is we use this service. Okay. Amazon Recognition Service. So in order to be able to use that one in Lambda function, for sure, we need to we need to back to your IM user, and then so get this IM user the permission to access what's my user. To access an Amazon Recognition Service. Okay. Okay, so I already add here Amazon Recognition Service. Okay, so here is I just simplify it, is for access. It's for access. Okay, just add this permission there, because otherwise you will get error message. You do not have authorized permission to access this service. Okay. So after you've done that one, I'm just like to we just implement the one. Okay, so but before we go ahead, I'm just like to very briefly talking about this. Amazon Recognition Service was launched in 2016. And video support was added in 2017. So, it is a service to analyze visual content included in an image or video. It is based on the proof highly scalable deep learning technologies developed by Amazon's computer vision scientists to analyze billions of images and videos daily. Yes, for sure. We use that one. Yeah, we don't need to have machine learning knowledge, okay? As long as you have some sense about machine learning, okay? So here is the types of detection and recognition, and we will for this one we will just use the labels, okay? Well, a label refers to any following objects. Let's say flower, tree, and events. Let's say wedding, graduation, concepts, as landscape, evening, or activities. Okay, so this is the label. And the faces, get information about where faces are detected in the image or video, facial landmarks, the position of eyes, and so on and so forth, and detect emotions. And we also, recognition also allow to do face search, text detection, and safe content. They really very powerful service, okay? So that's why I last week I read one article about the usage of the Amazon recognition is really widely used in commercial, okay? Commercial environment. So here is, yes, face detection. And here is, you can see labels. Okay, so emotion is a calm, sunglasses is no, mouth open wide, no, eye closed, no age, yeah, glasses, mustache, and beard, no. Okay, so this kind of things. Okay, so now here, yeah, this is what the object and the scene detection. So now I'm just like to, how about, are you ready? We like to create another lambda function, okay? So C# lambda. And again, use that one second time. I show you one more time using AWS Lambda projects. Right now they support .NET Core 3.1, .NET 5 is not supported. So we click next. Here is, I'm just using what? AWS Lambda 2. Lambda, just say lambda function. Lambda function to what? Okay. Image label, okay? Let's say I just put here. Image label, lambda function, or image label function, I put that one. And we are section 1. I just choose 1, okay? So I'm just using this. And this time for sure, I'm just like to use which one? We're talking about detect image labels, okay? Just to use S3 and recognition is just because this one we just like to say, okay, whenever use the update image to S3 bucket, and then so this recognition service will be what will be used to do add label, okay? Or we say detect image labels, okay? Choose this one, and I just click finish. They already provide really good. They provide a bunch of information there. So take a look here. Function, okay. So this time the function is pretty easy for us to understand because we're already very familiar with S3, right? Okay, so here is, yes, we say here is default minimum confidence, which means only the confidence about this label about 70%. We would just like to we just like to add this label to the image. Okay, so here is, you can see we use S3 client. Okay, and then so we use recognition, Amazon recognition object, and then so the hosted, because we're talking about what we're talking about image, right? So here is supported image type, PNG, JPG, JPEG. Okay, so here's the function. Okay, so the function here, you can see we do what we have. Okay, S3, we have recognition. So first we like to see the confidence, and then so after that you can see here is really the function, and this is the constructor again, right? We already know this is what this is. First we say is what parameterless constructor. Here is another constructor, and this constructor we provide. We have what S3 client object to have recognition and also have minimum confidence. Okay, so this is what. This is the function handler we're talking about. We mentioned this will be this lambda function's entry point. They have two parameters. The first one basically is input, and the second one is lambda context. Okay, so here is the input. The input here, we get what? We get records. Okay, so here is the records, and so where we get to this the input records, and this one we say, make sure it contains what the image type contains the whatever you input or upload it. Make sure only image will be only user upload image will be what. This lambda function will be triggered. Okay, will be triggered. Otherwise, you can see this one is not supported. And then so if it is an image, what we do here, you can see we just invoke detector labels. Okay, detector labels, and here is the detector labels request. Provide what minimum confidence, and then say here is the image, and then say here is the S3 objects bucket, and here is the key name. Okay, so after that. And we just like to add what? We just like to add this the label and label name and the label confidence to where? To the images tag. Okay, so let's say where's the image tag? If I'm just to go to the S3, okay. S3 storage. S3. I'm using this. Let's say here. I said this property, and then say if you go down, because I already tested that one. Here is the tags. Okay, so here is the tag name, and here is the confidence. You can see the confidence is 94%. Okay, here's the water, and have what 74. These things. Okay, because here is the let's see. I'm able to open. Oh, okay. I will just show you later this image. Okay, so this is what we try to do. Okay, so now if I'm just go to and show you another one, Daily Lily, right now, because I haven't when I upload this image, I did not the lambda function has not been published yet. Okay, so that's why there's nothing here. Okay, and so what we do here is just write to the tags to be this image's tag property. Okay, And then so here is what we try to do. Yeah, we write it. Okay, so we're already quite familiar with these things. Okay, for the S3, how we are able to add, upload, put, post, delete, this kind of things. Okay, so this is the thing. And then so this is was yeah, for sure when you do your lab 4 you need to modify this one, because lab 4 you're not asking to write this tag in this S3, but write this tag to where, to DynamoDB. Okay, so now we can what? We can test it. Okay, test it. You can see this time again we run it, and then so but this time here you can see the example request. Okay, so I'm just like you to bear in mind the request here. There's so many different types of request. Okay, so now here is we're talking about S3. Is that right? Okay, so that's why we choose S3 put. Okay, so I'm S3 put. Okay, so here's the record. Can you see that one? Moment ago in the code, in our code, we get what? Yeah. This is input records. Okay, so get this part of information. So that's why when you just come here, this is records. Can you see here? Okay, so records here, we have a bunch of information here. Okay, so basically because we're testing, right? Okay, so here is the event name. It's just a put. Here is object create. Here is the put. Identity, principal ID. Where we get this principal ID, for sure we need to provide our own ID. And then so my ID is here. Take a look. This is my ID. Okay, this number is my ID. Okay, so if I'm just back here, I provide my ID here. I guess we should provide the dash need to be removed. Here is the principal ID. Okay, so now here is the response. So this one I don't need to change, but S3 we need to change the specify the bucket name. Okay, so bucket name here I am just to use what? Here is my bucket name, because I like to whenever user update image to this particular bucket, I like this lambda function trigger. Okay, so one more time. Here is identity principal. Okay, so the principal, I'm just use. You just use your own principal for sure, right? Then so here's the principal. I removed that. Okay, so here we go. Get this one. And then so the partition, if you see the ARM, okay? So here's my bucket. The bucket name, I choose what? This is my bucket, right? You just use your own bucket. And this is the bucket. So what is the partition? And then so if you just back to your bucket name, can you see here? Here is the partition. For now is the AWS, right? So ARM, AWS S3, and then so here is a bucket. Okay, so back here, and this part I need to change to what? To AWS. Okay, so now here's the object. I do not have this one, but I have what? I like to take a look at this image. Okay. Yeah, I like to use daily. This one. JPG. Okay, so. Okay, so now this is my what? This is my input. So the input here, I repeat one more time, the event source is S3, okay? And then so the region, they will just get region, and then so here is just to use what, AWS, and then so here is your principal ID is your account ID, okay? And then so after that you need to specify what you need to specify, which bucket you like to associate with this lambda function. And then so after that, yes, because we're testing, right, I'm just going to test this one, test the daily. Okay, so let's say if I'm just back to the daily right now, the tag, you can see there's no tag here. Okay, no tag here, just a 0, right? Okay, so now I click, I hope it works, I click create execute the function. I click execute function. So how come is okay? So here we go. You can see a list of label have already found it, right? So the plant, flower, blossom, pollen, lily. This one has already put here, and then so when I back to my daily lily. Okay, so here you go. You can see this one has already done here, right? Okay, so here is, yeah, this 5 labels, which is greater than 70%. Here is the value is yeah, the 94 something, 90, above 90. Okay, above 90. It makes sense. So now it seems yes, that one works. Okay. It works. And then so okay, so you get it done. It works or not? Okay, so if you're not able to follow, you just watch this recorded video one more time. Okay, so this you can see it works. Okay, I could not follow. Okay, so it's okay, you just rewatch it. And then so now you can see it works, right? And then so what I like to do now here, I like to publish it. Okay, so very similar. Okay, I am just like to here is function name. I'm just using what yeah, image label function. Okay, image label function. So here is the handler. Okay, so make sure this is right. Lambda function, it seems not right, right? It's not right. So this one here is we use what? Image label function. Okay. Okay, so image label function, I think, oh yeah, image label function for section 001, function 001. Okay, so it seems okay now. I just like to, yeah, maybe I just use the name, okay, for section 001. I click next. And then I just keep the default one. Okay, so I just upload. It may take. Okay, it's okay now. Okay, so now what we can do here is, can you see, we can just configure the event source. Okay, so we are able to add here. Okay, so this time the event source are used to establish the connection between your AWS resources and the Lambda function. So we can add here, okay? So if I'm just click add, so here is Amazon S3, and then so here is my bucket name, right? Okay, so I click OK. I hope it works. Okay, so that one is already, it seems has little problems. So what I like to do here is, okay, easy way. I'm just like to back to my what? Okay, back to the Lambda. Lambda compute. Okay, so here we go. Here is Lambda. Okay, so right now, can you see right now I have what? I have three, right? Four Lambda functions. And that one is the one we upload moment ago, published moment ago. I click that. And then, so here is, this is the handler information is already here. Okay, the runtime is already here. Take a look at configuration. Okay, so now I am, it seems I do not have any sort of event source here. Okay, so now what I like to do, we go to add trigger. Okay, so I'm just add trigger. And then, so the trigger is what? Yes, it's S3, right? Okay, so the S3, and then so because, and then so what I like to do here is whenever user upload image to this particular bucket. Okay, so this is the source and event type, and all you can see all object create events. I'm just to choose that one. This is a bucket name. And here is all objects create events. So which means whenever there is new object to be uploaded to the bucket. Okay, so that Lambda function will be triggered. Okay. So recursive, okay, I'm just click OK. Okay, so we add error. Okay, so here is an error occurring creating trigger config overlap on the same bucket cannot share common event type. Oh, really? Let me see. Try one more time. Maybe I'm just let me just use, okay, because I already have what a function, because that one I'm already use this. Let me use that one. Okay, I just like to let's see details. Configure. Did I change anything? Let's see. Configure. This is the second Lambda function. I do not configure it. Yeah, I did not configure. Okay, let me try one more time. It's interesting. Okay, so now S3 bucket and use this. Yes, I choose because I like to choose this one. Optional Lambda limit. Yeah, I did add it. Right. The application notes. Yeah. Let's see what happened here. How come an error currently created trigger configuration overlap? I didn't see overlapped. Right now I don't have any. Okay, so do I have any? I don't think I have any configuration here, general info. I don't have it. Okay, click. Yeah, I do not have. Okay, let me see the trigger. I do not have a trigger here. Destination, no. Okay, so I should be able to say. Interesting. Okay, I just back here, take a look here. It's config. It might be because let me try one more time. It should be okay, but oh no. Okay, so I guess let me try one more time. Publish. I may need to. Okay, I may need to specify the VPC. Okay, so let me just use this. Let me try one more time. Okay, I may just need to specify the VPC here. Upload. Okay. Refresh. Okay. Try. It's always said event source configurations overlap. Configurations on the same bucket cannot share common event. I didn't do that one. Okay, let me see this one. Role here is this one should be okay. So yeah, this one is okay. And back to here. Function 2 minutes ago. Let's see. I didn't add anything here. Let me try one more time. Okay. Yeah, there's nothing here. Configuration. Okay, add one. Let's try. Should be okay. So let me see. Yeah, I need to figure it out. Sorry about it. So this always that is code. So it's okay, let me just specify one. How about I'm just say put, okay? Let me see. That is okay. Yeah, not okay. Recursive, maybe I just uncheck that one. Yeah, I have to check it. Can you see? I have to check it. I need to figure out what happened here because it works for me. By the way, when the function is in it is in Ohio. It is in Ohio, and then so this bucket is also in Ohio. I just double check it. I remember it is in Ohio. Yes, it is in Ohio. That's great.